This is Mr. Martin. This is a video for Pre-Calculus Honors. This is section 5.3. I'm going to start off with a warm-up that you should have completed already in class, and you can just check your solutions too if you like. And then we're going to go through 3 more examples for section 5.3. So for this first example, pay particular attention to the domain that I want you to find solutions over. So really we're looking for answers over 3 periods of the cosine curve. So we're looking for angles that have a y-coordinate of a half, so that's going to be pi over 3's, and it has to be positive, so that's going to be in the first quadrant, and that's going to be in the fourth quadrant. Now normally we would just have pi over 3 over here, and we would have 5 pi over 3 over here as we travel around the unit circle one time. But let's go ahead and take a look at the cosine curve over these 3 periods. So we're going to have 2 periods to the right and 1 period to the left. Each of these marks is a pi over 4. We're going to go up to 1, down to negative 1. I'm just going to sketch in a few points in here to help me graph this. So my 3 periods of the cosine curve are going to look something like this. Here's the first one, and then here's the second one, and then we have to go over, this is 4 pi over here, and we have to go over here to negative 2 pi. So I'm going to come down here and then back up and then to there. So something like that. So here's our 3 periods, and we want to find the angles where the cosine is a half. So here's my half value, 1/2. So basically if I drew a horizontal line at a half, I would want every spot where it would intersect here. So let's just go ahead and do that. So I have 1 spot right here, 2, 3, 4, 5, 6. I should have 6 spots where I have solutions. So these are just the 2 spots right here and here. This is my pi over 3, and this one is my 5 pi over 3. So I need to find the other 4. So I'm going to go one more time around my circle positive, then I'm going to go around my circle negative. So the one more time positive will give me these 2, and my one time negative will give me those 2. So x is going to equal, so if I went backwards this way, that would be negative pi over 3, and that would be negative 5 pi over 3. So I've got negative 5 pi over 3, negative pi over 3, and then pi over 3, 5 pi over 3. Okay, back into the first quadrant, so that would be 5, 6, 7 pi over 3. And then 1 short of 2 pi, so that would be 12 pi over 3 was 4 pi. So 1 back from that, so that would be 11 pi over 3. Okay, so these are all the solutions between negative 2 pi and 4 pi. Alright, moving on. If we want to just write 2 solutions for the problem that include all solutions possible, so we're looking for the general solutions now, it's a little bit simpler. We would just need x is equal to pi over 3 plus 2 pi k. Okay, that will give us all the ones that end up in that first quadrant spot. So all of the ones that are here, so this one, all the ones that are on that down part, that decreasing part of the curve. And then we need the ones that match up with the one in the fourth quadrant, so that would be 5 pi over 3 plus 2 pi k. Alright, so if you have questions about those, again, make sure that you ask me. Moving on to some examples. So for the first one, we want to find all solutions of sine x minus square root of 2 equals negative sine x over the interval of 0 to 2 pi, so over one period. So I'm going to go ahead and I'm going to add sine to both sides, so I get 2 sine x minus square root of x equals 0, and then solve that for sine x by adding square root of 2 to both sides and then dividing both sides by 2, so I get square root of 2 over 2. I strongly encourage you again to draw your circle. It doesn't take that long. It takes about 3 seconds, and then you have a visual of what's going on in the problem. So the sign is positive in the first and second quadrant, so I want the angles where the y coordinate is root 2 over 2 in the first quadrant, so that's pi over 4, and the second quadrant, which is 3 pi over 4. Okay, again, these are the angles that have a y coordinate, because it's sine, of root 2 over 2 and positive. Alright, so all solutions over this interval, we get x is equal to pi over 4 and 3 pi over 4. Okay, part B, find all the solutions. So now we're going to write our general solutions. We're going to have x is equal to pi over 4 plus 2 pi k, and we're going to have x is equal to 3 pi over 4 plus 2 pi k. Alright, moving on to example 2. Find all solutions. So I'm going to bring my term on the right over to the left. So I have tan x cosine squared x minus 2 tan x is equal to 0. Each term has a tangent in common, so I'm going to factor that out. So I get tan x times cosine squared x minus 2 is equal to 0. I have two things multiplied together that equals 0, so I know that one or the other has to equal 0. So either tan x is equal to 0 or cosine squared x minus 2 is equal to 0. This one's already solved for my trig function, so I'll figure out what angles go in there in a minute. Then I need to solve this one. I've got cosine squared x is equal to 2, and cosine x is equal to positive or negative square root 2. Make sure you don't forget that plus or minus anytime you take a square root and you're solving. So coming back here to the tangent, again, draw your little unit circle. We're trying to figure out where the tangent is 0. So that means the y coordinate is 0 and the x coordinate will be 1. So that's over here at 0 and pi. And we notice that these are equally spaced, so I can go back and forth from pi and then back to 2 pi and keep going around. So I only need one solution to hit both of these solutions, or one equation. So I'm going to have x is equal to, it's really 0 and then plus pi k. You don't need to put the 0 plus if you don't want to. And then from over here, square root of 2 is about 1.4, and there are no angles on the unit circle that have an x coordinate of 1.4 or negative 1.4. So from this we get no solution. Alright, so there's our answer there. Alright, moving on to example 3. I'm going to divide both sides by 9, so I get tan squared 4x is equal to 1/3. I'm going to take the square root of both sides. I get tan 4x is equal to positive or negative. When I take the square root of that and simplify, I'm going to get square root of 3 over 3. If you have a question about that, make sure you ask me. So now, we'll worry about this 4 in a minute. I'm looking for all the places where the tangent is either positive or negative root 3 over 3. And that's going to be at all of my pi over 6's. So here and here, I've got pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Now, when I divide these, alright, so let's go ahead. That means that 4x is going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay, so we're going to multiply through by a fourth or divide by 4, whatever you want to do. So I'm going to get pi over 24, 5 pi over 24, 7 pi over 24, and 11 pi over 24. This isn't going to give me all the solutions because I want all the solutions from 0 to pi. So what I need to do is I need to find more pi over 6's so that when I divide by 4, I'm going to get some more 24ths, but I want all the 24ths that are less than pi. So 11 pi over 6, the next pi over 6 is going to be 13 pi over 6. And then if I came all the way over to here, it would be 18, so it's 1 left, so that's 1 less, 17 pi over 6. 18 pi over 6, that would be 19 pi over 6. And then coming all the way around, that would be 24. So 1 less would be 23 pi over 6. So I've got these 4 more, and when I divide those by 4, I'll get 13 pi over 24, 17 pi over 24, 19 pi over 24, and 23 pi over 24. So this one is almost pi. 24 pi over 24 would be pi, and I want the solutions from 0 to pi, so this will be my last solution between 0 and pi. So make sure you pay attention to what you're trying to find so that you get all the solutions. If you only had these 4, you would only have half the answer. Again, if you have questions, feel free to write those down and ask me the next time you see me. And keep working on those homework problems, and we'll see you next time.